talk about the 24/7 water supply, what are the requirements, what are the challenges, and then what are the different modes of supply are possible, what are the emerging models in water sector globally, what is happening, and then what is the roadmap that we can walk in India for achieving sustainable and resilient water supply. Because in today's time, anything that we do is assessed based on two parameters. One is on sustainability, which is basically how much less energy we are consuming, how much good we are managing resources and all that. Plus climate change is causing a lot of stress, such as we are getting frequent floods, we are getting droughts. So in this new emerging challenges, how water supply system should be designed and operated. And in today's time, water supply, sewerage, flood, everything is related because of integration of these sectors. So how holistically we can look at this particular problem of entire water supply systems in India, that we have to understand. So first, let us understand water supply regimes, because always in our manual or any other textbooks, we have always been taught about continuous water supply. But there are other regimes also possible, which needs to be also discussed, evaluated and implemented. So typically 24/7 water supply is a continuous 24 hours, 7 days a week, entire year. The household is expected to receive water from the utility or municipal corporation. That we are receiving continuously water every day and every hour, and there is no break. So there are advantages of this system, that because pipes remain pressurized, contamination chances are less, but for achieving that there are a number of factors and scenarios needed on the ground to make this happen, to make this possible. And whether those conditions, those situations are available in Indian cities, that needs to be assessed and understand, and then we can have this very fantastic idea of 24/7, which is very valid. Nobody can deny that people should get 24/7 water. Definitely people should get it, there is no doubt about it. But at what cost, what feasibility, and then why we are failing as an entire, there are no good examples of replicable models of achieving 24/7 continuous water supply. So why we are trapped in this particular situation, let us understand. So in between supply regions, that we have 24/7 as a very ultimate goal and very nice goal. But what are the intermittent other regimes? So we have continuous supply, continuous delivery. That means we can supply water from source to water treatment plant to master balancing reservoir to the tanks. All are in one, everyone is in sync. Up to household, everyone is charged 24/7. That is continuous supply, continuous delivery. Then we have intermittent supply and continuous delivery. That means the source to WTP and WTP to MBR is intermittent. That means 18 hours, 16 hours we are pumping and we are stopping taking the water and we are stopping the flow. So that is intermittent supply, but continuous delivery. Your tanks are always full, ESRs, GSRs are always full, and they are supplying to the consumers continually. Then there is a continuous supply and intermittent delivery, which is a reality in most of our cities, that we supply from source to WTP to master balancing reservoir continually. Our pipelines may be charged for 24 hours or almost 20 to 24 hours. But from the tanks, distribution tanks, to the consumers, we have intermittency. And why that intermittency happens, we will discuss. And then we have intermittent supply and intermittent delivery. That means from source to WTP to MBR also we are intermittent, and from ESR, GSRs to the consumers, households, we are also intermittent. So these 4 regimes and 4 options we have to plan our cities, whereas our entire guidelines and discussion is always targeted to continuous supply and continuous delivery, which I said is objective, ultimate goal every city should have, but can be phased out, in a longer term. We have to address some immediate issues such as losses, such as revenue generation, such as consumer satisfaction, and then only we can go for a very large goal such as 24/7 continuous water supply. So technically what that means is that we have supply patterns at the source to MBR, from MBR to ESRs and GSRs, and then we have the demand pattern exerted by the household, which is maybe on the screen it is not visible, but typically in the morning we get very high demand from the consumers, and from the in the evening also we get some demand. But the peak factor, which is given in currently the old manual, CPHEO manual 1999, dictates this kind of peak factors, which is basically assuming that consumers are taking water directly from the municipality 24/7 fashion. That is assumed in the design, that is envisaged in the design, but what is implemented in the ground is very different situation or a scenario. So and what are the water supply engineers? The challenge that Pathak sir has said, that water supply engineers is a very challenging job in cities, because they are expected to supply water at a quantity of 135 or 150 LPCD. In rural areas, the norms are different. Then they have to supply at a consumption pattern. So quantity, not only quantity, but a consumption pattern. Then there is expected residual pressure. Currently, we are trying to match 7 meters of residual pressure, 0.7 kg you can say per centimeter square. So 7 meter of pressure that we want to maintain. We have to design this for 30 years or some mechanical parts for 15 years. And then admissible losses we have to control to 15%, and we have to give it good water quality, ISO standard water quality. So these are the challenges of water supply engineer. So they are always on a task to perform on these particular parameters, to provide the service to the consumers on these parameters. So what is happening in India right now is we are following this ISCD, that we have sometimes intermittent supply up to the ESRs, and from ESR to household it is definitely intermittent in most of the cities. And global scenario, it is not India's problem. Let us understand, and there is nothing that to that why it is happening in India, but globally intermittent water supply is there, and a lot of cities are facing this particular issue. Globally, in mostly global south, we have a problem of intermittent water supply, and even in the developed countries, the way they are managing 24/7 is pressurized, highly pressurized, but it comes with very high cost. Okay, so technically it is not very challenging to design a 24/7 water supply system. It is only who will afford that, what is the affordability and what is the reliability of that system. So Africa, Asia, Latin America, Southern Asia and India, we have tremendous amount of intermittent water supply. So it's a global problem, and many researchers and universities are working on this particular problem of how we can fix this problem. And there are also opinions that in current scenario, intermittency is also helping to reduce losses. How it is possible, we'll see. Okay, because if you have leaking pipes which are have very high loss, maintaining 24/7 will require more water than intermittency, and there are studies regarding this also. So what is the reality we have? We have intermittent water supply ranging from 30 minutes to 12 hours per day, alternate day to once in a fortnight. Cities like Latur, Jalna receives very little water once in a week or in that situation. Another issue is, even if we get water, there is inequitable distribution. That some societies, some areas receive more water than required, and some areas do not receive water at all, and they have very issues of inequitable distribution. Our government ministry is trying to fix the access problem. That first of all, providing access. Jal Jeevan Mission has started, it was 18, in rural areas we had 18% of household connections. Now if you check Jal Jeevan dashboard, it has 64%. So access is there, but whether we can provide the water reliably in all seasons is a big next target. And in cities 60% coverage is there. And then situation is similar irrespective of water availability. So some people may get confused that there is a water scarcity, hence intermittency is there. It's not the situation like that. It is also because of water that is available but not supplied properly, not managed properly. For example, I visited cities like Ahmednagar, Nanded, where water availability is not a question. Godavari river is there, so water is there, but we are not able to distribute it properly, and there is alternate day supply. And also there are some areas receive water once in 3 days. And this is news in Lokmat this year in April, where you can see how our 20 cities, big cities in Maharashtra, and if other cities also, other states also will study similar situation, will find. So 16 cities in Maharashtra receive intermittent water supply, but daily. So daily getting water, people will be happy, people will not complain. as Patak sir has told, that if they receive water in the first in a particular hour reliably, consumers are happy. They are not demanding for 24/7, because they are anyway storing, anyway treating in the house and then consuming. So their requirement is to supplying daily. But there are 14 cities which receive once in 2 to 4 days. 4 cities receive once in 5 to 7 days. Bid receives once in 8 to 10 days, and Jalna receives once in 10 to 12 days. So this is the reality we have in our cities, and nothing to be particularly about Maharashtra. This is the scenario in entire country. Okay, this is just news from Maharashtra. But if you see the other news, everywhere there is a problem of pipe bursting, leakages. Nagpur city is struggling most of the area for getting water. In some parts it gets alternate water day. Pipe burst in Kerala, Hyderabad, PCMC, and why 24/7 is remaining as a pipe is a dream for many cities. We will discuss that. Okay. So I have studied these water supply systems across India, whether it is rural area, urban area, variety of projects and research investigations. We have studied schemes and programs of different governments, different municipalities. I was part of one of the large project of water audit, where we have studied the water audit of around 30-40 cities, and the losses in the systems are 30 to 40%. In some cities it is 50%. So what is happening is we have tremendous amount of losses. Our pipe upkeep, pipe maintenance is not good. So whether it is the effect or cause, if you try to do a management study and try to see whether it is an effect or a cause, we are in a situation where we do not know whether it is an effect or whether it is causing something else, because we are trapped in this particular vicious cycle of water supply system failure. What is vicious cycle? You start from any point and you will reach back to the original point again. That means we are trapped in a circle that our infrastructure condition is very poor because of lack of good planning, lack of good analysis tool, lack of good relevant design methods. We adopt design methods suitable for developed countries. Very, some very advanced sophisticated software tools which are not relevant to Indian conditions. We just adopt those tools blindly and try to design in offices and then implement. So we have tremendous amount of problem in design and analysis itself, that our designs are very theoretical, those do not correlate, match with the ground reality, and then when contractor implements that design, there is a failure, but nobody challenges what consultant has designed and what was envisaged in the DPR and what is happening on the ground. So that is the situation we are having, and that leads to a poor infrastructure condition. Then we have poor service, that leads to a poor service quality. That means people are not getting reliable water supply. People are getting alternate day, people are getting low pressure, neighbor getting more water, you are not getting enough water, so people start using the pumps and other interventions. So those things start happening, and as service quality is poor, consumer satisfaction is poor. So consumers are not happy for that particular service, and then that entirely affects the revenue, because if consumers are not satisfied, the bills if you want to raise to cope up with the operation and maintenance cost, most of the capital cost comes from state or central government funding, or some innovative projects or 24/7 projects come from some multilateral agencies such as World Bank or Asian Development Bank. But the issue is, even if you have capital cost, who will maintain for next 30-40 years is very difficult, whether it is water supply infrastructure and sewerage. And in this seminar we have some experts talking about how to finance this particular infrastructure. The problem is the revenue is not generated because consumer satisfaction is poor. So tariff policies cannot be enforced, like telescopic tariff policy cannot be enforced. Then we have poor operation and maintenance. Because we do not have good funds, because of poor revenue, we have poor operation and maintenance. And that, so supply durations are low, asset management is not maintained, municipalities do not know where is the pipeline laid, when it was laid. Those kind of issues are there. No maps are available with the municipality. So that leads to poor operation maintenance. That further degrades the infrastructure condition. So where we are reached? We are reached to square one. So this is called vicious cycle of water supply, and it will not break by just putting a new infrastructure again and again. So what is the approach in all our projects and missions is that lay new pipeline, construct new tanks, lay new pipelines, construct new tanks. That has been the DPRs I have seen in many cities, and there is no retrofitting, no theoretical, no thorough understanding of the ground reality. That is the problem. So we have documented this in our research projects, the entire vicious water cycle of intermittent water supply in India. So let us understand why we are then not getting 24/7. What are the technical challenges? Is it such a technically difficult issue? If you open 1999 water supply manual, it dictates 24/7 guideline. We do not need a new consultant or a very good, some international consultant to teach us how we should have 24/7 in our cities. Yavatmal is Yavatmal city. It is such a fantastic example. Maharashtra Jeevan Pradhikaran, since from 1972 to 1984, with the floating reservoir, has implemented 24/7 in that time. We have just not documented it, and we have not replicated it enough that this goes to our current practice of creating water infrastructure. So there are very good examples from Maharashtra Jeevan Pradhikaran and different state departments for doing things differently and innovatively, but we are not following our own practices, good practices. That is the issue. Now our entire discussion right now is developed countries has 24/7. Why we do not have 24/7? The reason we do not have 24/7 is not technical, but there are many other socio-economic conditions. What developed countries, and any textbook you open, any manual you open, is they have this kind of arrangement, which the average flow comes from the pump, and city is served in the middle of the pump station and the tank, and you have this floating reservoir. What is floating reservoir? That inlet and outlet is same. There is one pipe. So what is happening is that one inlet and the same pipe will function as an outlet. So during the non-peak hours, water will come down from this tank, and during the peak hours, water will come from this tank and also from the pump, and during non-peak hours, water will rise to this tank. One benefit of this system, and which is the beauty of design, is that system will decide its own operation because it is a floating reservoir, and nobody can predict very accurately what is the current demand, instantaneous demand in the city, right? So it is very difficult to predict. You can assume, you can do population forecasting, you can do some studies, but instantaneous demand prediction is very difficult, and that's why floating reservoir design offers that flexibility in the design, such that the system decides its operational on its own. And what is the new thing developed countries are doing is not new thing, but how they are managing is they design their system not for maximum day demand, not for maximum hour design, but maximum day plus fire flow. So their systems are equipped to take out the water during fire flow also. So that is the benefit of this particular arrangement. Now, whether technically it is difficult to design, so many experienced practitioners are here who can design the system. Then why we are not adopting this? The issue is the residual pressure required to maintain in this particular system is 17 to 50 meters. That's too high pressure you have to maintain. And to maintain such a high pressure, you need a good, very high quality pipes and very good operation and maintenance protocols at the municipality, which typically are missing right now. And we are growing. We as a country, we are growing, we are learning, we are experimenting. So nothing to blame to any municipality or anything, but suddenly if you say and one zone you try to do 24/7, that's why we are failing, because the upkeep is not happening. Somebody can replace all the pipes, bring new infrastructure and supply more water and do 24/7. That's technically not a challenging problem. How you can do with a low cost, low resource, innovatively 24/7 is a need for and we have to do it in our own way, not what developed countries are doing. Because this technical design is very easy to do. The socio-economic concern is who will bear the cost. If I had to, currently there is no demand because people have invested in the storages, household storages. Everybody stores in the sump or overhead tanks, which is not assumed in the current design. So our design guidelines do not match with the ground reality. And how we are managing then? We are managing that whether by gravity or pump, we raise the water to the ESR or GSR, and then we supply to cities. Now the pressure that we are trying to match is 7 meter, 12 meter or 17 meter. Typically I have not seen the average zonal pressure reaching more than 7 meters in cities. So we have not achieved 7 meter as a benchmark yet. We are still struggling to achieve good pressure everywhere. So the hydraulic model that we use is assume that the water level is at the lowest level of the tank. That you start your level from the lowest point in the tank, that is the worst condition, and we design the entire system from here. But what happens is the withdrawal capacity. What is withdrawal capacity? Consumers fetching water because they have not received water for last 23 hours. As soon as supply occurs, they try to fetch all the water in one moment. So the withdrawal capacity is too high than the supply. That gets the tank empty. So our tanks get immediately empty, and then the further HGL drops and the standing column situation occurs. In many municipalities, I have observed tanks are bypassed. Many cities are bypassing the tanks. The transmission lines or the bulk transfer lines are attached to the distribution. That is the scenario we are operating with. And this is the operating level which have to understand that what operating level then actually your tank is performing. This kind of measurements we are doing in variety of cities, and this is one video in our lab which shows that if the withdrawal is very high, you have the water level going down. So water level is somewhere. So water level is somewhere here. Okay, tanks are always running at low, whereas if they are not at that level, air entrapment happens from the tank itself. And we have air water mixture in the network, which is very difficult to predict how it will behave in the entire water network. So we have air entrapment issues in the system. Our tanks are having issues with of filling at the full level, operating at the full level, and also intermittent water supply, which adds air in the system. And talk to people who operate, and they will tell you what are the difficulties they are facing to take out air from the system. So our hydraulic models do not take into account such kind of scenarios, and in a routine design of DPR preparation. So our operating levels are somewhere in between. So based on this, we have developed some new methods of hydraulic modeling. So with this particular confirmation after lab test, we have gone to many places, studied. This is one city where they had a overhead reservoir, and 16 meter staging height was there, and what we observed after 40 minutes, tanks get empty because too much of withdrawal. So this kind of ground validation I don't see in the DPRs. That kind of ground studies are not happening, and we are just assuming there's some theoretical design of 24/7, and I think that we will achieve 24/7, which will not happen. Then what is happening then? Then on ground, our field engineers are facing tremendous amount of challenge to supply water, because the design is talking something else, ground reality is something else. What they are doing then? So what they are doing is, typically the land is allocated only at one place. That's the municipal planning issue. That tanks need to be distributed across the city equally. Then only the hydraulics will work. And that's the hydraulic engineers we have to communicate with the municipality. All the lands are allocated only at one location, and there are no DMS district metering areas, and it is impossible to implement these district metering areas because of too much of segregation needed. And in India, a lot of political interference happens on ground. So you may do DMA in the design, but after 1 or 2 years, people will fall out of the DMA and interconnections will be there. No control on withdrawal. Even if you consider 10 liter per minute as a flow from the tap, 10 liter per minute, multiply by number of consumers, you will estimate how much withdrawal capacity, which will be much more higher than the supply. So your tanks will ultimately get empty. So what the resort they have, the operators or the field level engineers, is to create small zones like this, 2 small zones, put the wall, another wall, operate one wall for 30 minutes. Sorry, the screen is not showing the animation, but one zone they will supply for 30-40 minutes, they will close the one wall, open another wall, and supply next zone. So in the city, one zone has many operational walls, that is increasing the wear and tear, that is reinforcing the vicious cycle. That's what I told in the initial slide, that we are stuck with this particular operation, which is reinforcing the poor performance of the system. So the big challenge is whether the current hydraulic modeling is relevant. The current hydraulic modeling is demand driven. That means it assumes that consumer is wise, they will close the tap when the water is not required, they have meters, but that's not the scenario. So our hydraulic model, and they do not have storage. but that's not the reality. Every household has storage. So our hydraulic models in the practice, that is practice, is not relevant in the current time. So we have developed a new hydraulic modeling method called flow star water networks. How we can model the flow star situation. That is one of the research projects for my PhD student, who has developed a new method of flow star water network, because whether it is transmission line or distribution line, we have flow starvation as a phenomena. And then we have to take into account, so what we should do, we have to take into account household storage capacity in the design. We cannot keep it ignoring, because the manual says this is the consumption pattern, but in between comes the storages, and unless we account for those, we will not able to successfully operate the system. So consumers have periodically invested in household storages and modular water filters. Okay, so they are basically happy if you supply for 1 hour with good pressure and good flow. So, and this is from village scenario. Go to any village, so many drums and plastic containers they have to store water for 2 to 3 days. And you go to housing societies, they have big sums, 2 to 3 days storage in the housing societies. So whether rural or urban, we have same scenario, and hydraulic design models have many data gaps. So if somebody is saying that I do has hydraulic model and everything will be solved, it is not the situation. The ground reality is very different. We have air entrapment, we have tremendous data gaps, we do not know what are the pipe situation on the ground. So we have to take hydraulic models as a decision support and not the final decision that because hydraulic model says this, everything will function properly. That's not going to happen. So what is the quest for 24/7 water supply in India? Where this quest is coming from? So basically in 2003, the government of India started this particular initiative, that it is essential goal of cities should be 24/7 water supply. I told you that there is no disagreement about it, that we should have 24/7. And there are a number of pilot projects in Karnataka. World Bank has funded this particular initiative. They have tried, but there are no replications. And based on the evidence from developed countries, that continuous water supply has benefits, but it comes with a cost. It cost of higher tariff, cost of better operation and maintenance requirement. So the question is, what is the current reality of scaling up of 24/7 water supply to the majority of cities in India? We have forgotten the service level benchmarks altogether. That was the initiative started by the then called Ministry of Urban Development in 2008-12, and we have not achieved the basic service level benchmarks, but we want to plan for 24/7, which is I think it cannot be a goal for cities to directly jump from not achieving service level benchmarks to 24/7. And as far as the pressure is considered, this is again from our field lab, which shows that even if you have good amount of 4 to 5 meter pressure, 10 to 15 liter per minute flow will come. So our job is to provide good pressure first of all at every household, which will lead to a good flow. Hence 7 meter of residual pressure is good enough for operating any supply system. Okay, if somebody wants more than 7 meter, that has to be justified. Who will bear the cost has to be justified, and it is also international practice. Thames Water UK, which runs the system 24/7, but their design guideline is 10 meters. 10 meters they are expecting in the ground. So there is no need to revise the current guidelines of 7 meters, because we are struggling with achieving 7 meters first of all. The issue is, if you raise pressure in the system, it will lead to higher losses, because pressure and leakage rate is directly correlated. So if you have higher pressure, more leakages will occur in the system, and so unnecessarily if you try to pressurize and try to do 24/7, more losses will occur, more water consumption will happen, and that will lead to more economic losses to the municipality. What is happening is bulging on infrastructure cost. People want to bring PPP, and there are experts of PPP here going to talk about it. But what I observed is normal DPR requires a retrofitting, but for the sake of bringing public-private partnership and many other things, DPRs are bulged with new pipelines, new household service connections, new metering, and many other things, automation and SCADA, which may not be relevant for a particular municipality, and unnecessary inclusion of new components is happening. The cost is inflated, and the DPR is made as bigger And that's what everybody wants, because bigger DPR means everyone is happy in the entire supply chain. So that is what I observed as an academic viewpoint. And this is the financial sector, burden on the public sector, because unnecessarily if you are replacing all the pipes, bringing automation when not required, it is the financial budget problem. So there are resource constraints in the 24/7, such as ULBs have financial constraint and rely on one funding from national schemes. Average connection cost, and maybe correct the data, is around 10,000 to 20,000. For every city, the connection cost varies depending on the topography. Hence, investment required is rupees 1.2 to 2 lakh crore. From where this funding will come if we keep replacing the pipes and bringing new such kind of projects? And we will never be able to cope up with the new infrastructure that will lead to 24/7. So we have to take the retrofitting approach, because even GNRM and Amrut has limited funding. It's not like infinite funding is available. Hence, there will be no sufficient funds available anytime. Let us understand this. People are saying, oh no, we have fund, but you have fund for 5 years now. What will be the upkeep of the system after another 5 years? So we have to do the things differently. So the cost of connections we have to declare in each project. And at the same time, increasing tariff is extremely difficult. So you not in the financial statement, DPR may have a assumed tariff system, which when the operator or municipality goes for implementation, there are tremendous amount of oppositions. So again, we are back to the square one, no funds for maintenance. And availability of water resources is sometimes constrained for 24/7. And what's wrong with the 24/7 model then? Assumptions and flaws. The models of 24/7 that have implemented in India that assume that there will be good engineering and management practice, which is missing in the country. Even if you operate a private operator, the upkeep remains poor. Lack of understanding of drivers for intermittency, that why our systems which are converted to 24 again shift back to intermittent mode. Supplying more water. So one zone you can supply more water 2 times, 3 times and declare it as 24/7. Is it wise? Is it a 24/7 strategy? That one zone you can replace all the connections, new pipelines, supply more water and declare 24/7. I don't think that is a true 24/7 in any sense. Bias in the pilot selection. The peripheral zone will be selected as a 24/7, the easiest, not the core hardcore city. And the selected projects, pilot projects have low cost. So anywhere you go, they have low cost than the other city zones. And consumer behavior. Consumers, I have seen many 24/7 projects where consumers anyway store in the house. They will not give up their storages. So they will anyway store, filter, and they then drink. So what? And there is a floating wall in the tank. Floating wall will be closed because whenever the tank gets full, floating wall is closed. So consumers are anywhere withdrawing from intermittent mode. Then why this particular entire we have to supply 24/7 needs to be assessed from case to case basis. So is it prudent to supply water 24/7 in water network having losses of 30 to 50%? Because you may lay new pipelines, but they will again 5-6 years down the line, they will have more losses. Okay. So that questions this wise crowd can decide whether such a scenario is to be implemented. And then I'll talk about why we need alternate pathways then. So water management is a wicked problem. Wicked problem is approaching it from any side is very difficult because we have not understood the problem correctly first of all. So shooting any solutions without understanding the problem creates more problem than the solution itself. So there cannot be one solution fits, one size fit all solution. That somebody decides at one level that everyone should go for this will not work in our country, which is very diverse. Each city has its own, different topography. Central areas has different demand, peripheral areas have different demand. So one solution will not work everywhere. Even pipe in water might not be safe because pipe water supply may also have contamination. So people are always resistant to drink directly from the pipe. So they will always use filter. And ultimately the treatment and the quality part is left to the consumers, whether said or unsaid manner. Household product models are not scaling up. Then we have household product water filters, but we are also spending on water treatment at the main distribution system level. So people's ability to take personal responsibility is shaped by their circumstances. They will observe, if I am getting 1 hour water, if I am getting contaminated water, they will install the filters, and that has happened historically now in India. Even the slums and communities have community drinking water arrangements, jar systems that they get from filtration systems. So research regarding safe water has focused on point of use or point of collection models. Now the developed countries are shifting to not a centralized water treatment system but a decentralized water system, because treating it centrally, bringing it to the consumer will again add the contamination. So people in developed countries, the research is going on how we can supply treat at the point of use, whether at the household level or at the community level. So safe drinking water is often conveyed as a short-term measure with no discussion of when long-term measures will be implemented. So only the short-term, some initiatives will be taken. So why we need alternate pathways? As I said, it is a wicked problem, and a 24/7 system is financially unsustainable, very high operational and maintenance cost, and more data other speakers may show. Safe water quality is not ensured even in 24/7. No replicable and sustainable model exists in India. Emerging contaminants is a big issue. Fortunately, Mumbai has surface water sources, but many cities rely on river water or groundwater, and those are getting contaminated. So even if you have the treatment, that treatment will not remove emerging contaminants such as microplastics, pesticides, residual pharmaceuticals, and very toxic pollutants that are available in the river system nowadays. So we need to rethink this entire problem. Hence, need and feasibility of 24/7 has to be taken into account, and focusing on treating the required quantity of human consumption, because we need 3 to 5 liters of water for drinking, and treating the entire volume of 135 to the highest quality, we have to think now that can there be any other alternative model, and those kind of experimentation needs to be done. So diverse and distributed water systems with provisions of circular economy, because circular economy is needed in today's time. That means we have to recycle, reuse, reclaim the water in our systems, and then segregate the drinking water quality from other quality of water, so that effectively we will bring sustainability and resilience to the system. So and scale decentralization, that means we have highly centralized systems, one water treatment plant entire city. That will not work in future, because if that plant fails, what the city will do? Delhi had flood problem, and entire most of the Delhi was affected. So we need a scale decentralized system, smaller systems, not very small but scale systems, but decentralized way. That is the way, that is, I call it leapfrogging. What mistakes developed countries have done, we have to avoid, and we have to leapfrog to a more wise, more better systems in our context. And we have to, I have a strong belief that our engineers in municipality and state governments have good capacity. They need to give a better chance to design systems as they want, because centralized systems comes with high capex and opex. And even if 24/7 supplies ensures water that meets current standards, residents still will use household filters, because they will be always worried about water quality. So focusing on treating the required quantity ensures cost effectiveness. And instead of replicating the infrastructure models by developed countries, because most of the times we are following what developed countries have done and not what our country needs. So innovative and sustainable solutions are needed that will help us in long run. So emerging ideas are small non-grid systems, small grid systems, and hybrid systems. These kind of 3 systems we need to follow and experiment, and not the 24/7 kind of system always. So in summary, water management presents a complex and multifaceted challenges. There are tremendous amount of challenges in this particular arena. Solutions to water management problems may have unintended consequences and require adaptive strategies, because if you do not keep flexibility for next 20-30 years, we will be stuck in the system for a very long time. Breaking the vicious cycle of water supply system requires meticulous planning, which focus on infrastructure development with retrofitting approach, not the new infrastructure approach. So we have not worked on retrofitting approach. So municipal and local capacity building and financial viability need to be taken into account, because if we do not take into account this municipal capacity, we will not able to cope up. So the potential benefits and drawbacks and affordability of 24/7 has to be taken into account before its implementation and not after implementation. And alternate ways of water provisioning, that I said that there are no other innovative models implemented, that whether can be segregate drinking water quality from other water quality, whether we can use small scale system, gridded system than a centralized system. Those programs and missions or innovations are not happening. So I think we have to walk on that path than only just replicating 24/7 as a one and only solution for our water supply systems. Thank you.